Okay, so the next type of volume we're going to look at is something we call cross sections. So we think about cross sections when we talked about the disk method, and then a little bit about the washer method. We talked about cylinders. We talked about disks, and when we looked at it, we looked at a circle. That's what we cut. And so when we think about a circle, we had an area, and the area was pi times our radius squared. And we had all these circles were lined up. But what if I said that I had, and then we said our volume was really the integral of our area times, however, let's say this way would be dx. So an area is a function of x. Okay, and here our radius was y, which was some function of x. And so now what I want to think about is well, what if I didn't have a circle? What if I had something else? What if I had a square? Now, revolving seems a little bit weird, but maybe I want to figure out what this volume was. And as squares, well, if it's just this, you have your area, whatever it is, okay? And we talk so the area here would be a square. And then we have h here, so my volume is side squared h. And remember, same thing in geometry, our volume was the area of the base times the height. And our height is what we're integrating on, and our area of our base is what we're going to be interested in now with cross sections. So think about the different areas. Now, this looks pretty straightforward, but what if I had some function here, right? And that was what the squares were on. So the squares would change, they're standing up, maybe lose the x-axis here, but they're standing up, and so their side keeps on changing. Here's side 1, here's side 2, I might have a side 3 over here. So that's varying with my function, okay? So if I know that my square is y, right, which is f of x, then my area of that square would be that squared, right? And my volume would be my integral from wherever I'm going, again, of the area dx, right? Because they're all those squares added up. So that's basically what cross sections are doing, and we can use all different types of shapes. We can use squares, we can use rectangles, we can use triangles. Remember, if you have a triangle, the area is 1/2 base times height. And if I have a right triangle, that's pretty easy because I have a base and a height, right? And if I have other types of triangles, it's not that bad. But what if I have an equilateral triangle? So if I have an equilateral triangle, and this is my base side, when I bring down this here is going to be radical 3 over 2 times the side. Remember? And this here is half the side over 2. Think about our equilateral triangle. So that might help us. So an area of an equilateral triangle is 1/2 the base, which is s, times the height, which is radical 3 over 2s, or radical 3 over 4s squared, which might help us with something later on. I also gave you some pictures here so you can see better than me drawing them in 3D. Here is something where I have a cross-section of a square, and the square, the side is probably 1/2 the distance. Here I have triangles, equilateral triangles, and see how I have my circle here, and so I know what my side is, that length there. Rectangles, so these are cross sections of rectangles cut across. I have here is, I have my function, right, and this cross section is a square, and here also I have the function that looks like that, and see how my cross sections of squares are. So they can look kind of interesting, and you can look on the internet and find some more examples and in your book as well.